This is our question number 5. So here you can see the denominator have already factorized, but the second part can be factorized. So first we have to factorize and write that. So if we factorized, we will get in the denominator x, and if we factorize the x squared minus 4x plus 3, it will be x minus 1 and x minus 3 with the respect to dx. So here we will do like our same method. So here just see, there's one thing to tell. Okay, so if we write a over x plus b over x minus 1 plus c over x minus 3. So here we are having three constants. So if we expand them or if we cross multiply them, we will get a into x minus 1 x minus 3 plus b into x into x minus 3 plus c into x minus 1. So here it's easy to do in the way that making x or one component 0. So when we take x as 0, we will get the bx part, the second part, and the third part will be 0. So we'll take x as 0 now. So when x is 0, yes, so if we substitute in the LHS, we will get 3, and if we in the RHS side, we will get nearly 3a. So a is equal to 1. So okay, so to make the second component 0, here's a minus 3. So if we take that as plus 3, we will get 0 for the second part and also the first part. So we will get the answer for C. So if we substitute 3 there, we will get 3 into minus 9, 3 into minus 12 and minus 9 equal to minus 18. That is equal to 6 into C, because x is 3 and x minus 1 is 2, so 2 into 3 is 6 into C. So C is equal to minus 3. Okay, so we have to know about the B1. So we have to make the last part as 0. So there is minus 1, so we are taking x as plus 1. So if we take x as plus 1, if we substitute in the LHS, we will get minus 2, that is equal to minus 2b. So the answer would be b is equal to 1. Okay, so next we know how to do the next steps. So it will be the usual procedure. So if you want, you can write the question again and can do, or else you can write without writing that, but if we write that, it will be clear more. So it's equal to a is 1, so we don't have to put that. So in integration of 1 over x with respect to dx, b is 1, so plus integration of 1 over x minus 1 with respect to dx. Here c is minus 3, so minus 3 integration of 1 over x minus 3 with respect to dx. Okay, so we know how to do that. So ln x plus ln x minus 1 minus 3 ln x minus 3 plus c. Okay, so it's like the it is the log function. So we can write, if two logs are adding, we can write them as a multiplication. So we can write them as ln x into x minus 1, and here if we subtract, it will be a division, and if we write something in front of log, it will be the power. So we can rewrite that as over x minus 3 power of 3. You can put different brackets to verify them, plus c. Okay, this is the question. You can rewrite them as per your wish or as per the question. So this is our 6th question. So if we do the 6th one, if we factorize the denominator, we will get x minus 1 and x minus 2. So if we write them, this part would become here. So here we can put a over x minus 1 plus b over x minus 2, but think there is a x squared in the LHS. So if we multiply the two denominators only, we will get the x squared value. This a over x minus 1 plus b over x minus 2 won't give the answer or the form in the left side. So here we can put a constant c to get the x squared, because it can be multiplied by those two denominators. So if we cross multiply them, a into x minus 2 and b into x minus 1 plus c into x minus 1 and x minus 2. Okay, so that is equal to 2x squared plus 3x plus 7. Okay, so we have to make everything 0. That is the easy procedure, because if we expand them and rewrite them, that will take much time. Okay, so when we have to put x as plus 1, because we have to find the value of a, so we are taking x as plus 1. You can do whichever order you want. So if we take x is equal to 1, it will be 12. 12 is equal to 1 minus 2 is minus 1, so that will be minus a. So a will be minus 12. Okay, when we take we have to make the a component and the last component at 0. So we are taking x as plus 2, because there's a minus 2. So we are taking x as plus 2. So if we substitute 2 in there, 4 into 2 8, 6 and 7 is equal to 21. That is equal to 2 minus 1 1, so b. So b is equal to 21. And see, there's a c there. anyhow we will get c as 2 because there's only one x squared, so that is equal to c. So c is equal to 2. Then we can substitute. So be aware of what is the constant for your factorization. Don't write them disorderly. So if we write them integration, so 2 is a constant, so 2 into dx plus there will be a minus 12 for b, so minus 12 of integration of 1 over x minus 1 with respect to dx, and plus 21 because b is equal to 21, so x minus 2 with respect to dx. So if we write them, 2x will be 2x minus 12 into ln x minus 1. It's a ln function, so x minus 1 plus 21 into ln x minus 2 plus c. Okay, that's our 6th question. And we will see the 7th one, a little bit tricky. Dx over 9x squared minus 12 minus 1. So here first we have to factorize the denominator. So how to do that? Okay, so we can see it will be not in our anything. We have to use some of the mathematics things we have studied earlier. So just think the first component is 9x squared, so we can write it as 3x whole thing squared. So it's like a minus b whole thing squared. So a squared minus 2 into a into, so a will be 3x and we want minus 12x here, so if we multiply by 2 only we will get that 12. So b will be 2, so 2 squared we want minus 1, so we have to minus 5. So if we write this 3x minus 2 whole thing squared 2 minus root 5 the power of 2 we can write. So it's like a squared minus b squared, so we can factorize them a plus b, a minus b in that form. Okay, yeah, the question is over. So just simply substitute the values and go for the answers. So a over 3x minus 2 plus root 5 with respect to dx plus b over 3x minus 2 minus root 5. Okay, so now we have to do the procedure. So if we write dx, so there will be a 1 there, so 1 is equal to a into 3x minus 2 minus root 5 plus b into 3x minus 2 plus root 5. So we just here we have to expand because there's no other choices, so it will be 3a plus 3b into x. I'm writing the last line. Okay, so here minus 2 minus root 5 will remain, so we can write them as plus a into minus 2 minus root 5. If you want, you can rearrange it, right? Okay, that's your wish. Plus b into root 5 minus 2. So see, there is no x component here, so we can write 3a plus 3b is equal to 0. So from this we can write a is equal to minus b. Yes, this is our first solution. So let's get in the second one. I have to find the a and b. So we can write the next set. So a into minus 2 minus root 5 plus b into root 5 minus 2, that is equal to 1. So if we know that a is equal to minus b, so b is equal to minus a. So we can rewrite them as we know. So if we rewrite them and if we solve them, if you solve it, you will get minus 2a plus 2a. So a is equal to minus 1 over minus 1 over 2 root 5, and b is the minus value of a. So b will be plus 1 over 2 root 5. Yes. Okay, then we can simply substitute the values and go further. So there's a minus, this a and b are constants. So if we write integration of dx 9x squared minus 12x minus 1 is equal to, we can take out this constant parts out. So and integration of 1 over 3x minus 2 minus root 5. Yes, sorry, there's a plus for a, so plus won't be added. So 1, okay, dx, and plus b, so that's also 1 over 2 root 5, and can be written 1 over 3x minus 2 minus root 5. So we can, if we differentiate the denominator, we will get 3, no? So 3 is a constant, so we can add the constant in the up to make it as a log function. So 1 by 3 will comes out. So dx, it will also be in the second part. So if we calculate, we will get 6 minus 6 root 5 ln 3x minus 2 plus root 5 plus 1 over 6 root 5 ln 3x minus 2 minus root 5 plus c. Okay, so if you want, you can rearrange as taking 1 over 6 root 5 as a common thing, or write the minus 1 in the back and the plus 1 in the front, or in the log form like multiplication and division. So I am writing as a log function, so it will be the seventh one.